Last week, millions along the East Coast braced for something serious. The Storm Prediction Center had highlighted a significant severe weather threat. Inside the SPC in Norman, Oklahoma, the forecasters watching this setup weren't taking it lightly.
All the pieces were there that it was a very concerning environment.
Then the day arrived, and for much of the East Coast, the threat diminished. The cold front passed, it was windy, but no tornado outbreak.
It was a somber mood in the operations floor because we realized that, we had messaged a higher end event that was not going to occur quite the way that it seemed to be. And, that's not really what we want. I mean, we're really trying to target the best possible forecast.
Almost immediately, there was backlash, and some meteorologists began to apologize. But that reaction is exactly why the Storm Prediction Center is rethinking how it communicates risk in the first place. Because forecasting severe weather is much more than drawing lines on a map. There's real science behind these outlooks, and they're more accurate than ever before. Today we're going off the radar and inside the epicenter of severe weather forecasting. Evan Bentley from the Storm Prediction Center joins me to break down the research behind their new and improved outlooks and the ongoing challenge of conveying risk, intensity, and uncertainty to the public. Because sometimes the difference between a bust and a forecast that did its job is simply how well we understand the forecast in the first place. I'm meteorologist Emily Gracie, and you are listening to Off the Radar, a production of the National Weather Desk. On the show, we dig deep into topics about weather, climate, the ocean, space, and much more. Our goal is to help you better understand the weather and to love it as much as we do. Ed Piotrowski, I am so glad to have you on the show today, mostly just because I love chatting with you. So it's wonderful to see you and to have you on Off the Radar, frequent guest, I think, at this point, right?
Yeah, I love it. You do such a great job, Emily, and it's always great to see you.
Yes. All right. So for those who don't know, Ed Piotrowski, chief meteorologist at WPDE in Myrtle Beach, a place that thought maybe there was going to be some active weather this week. Things changed a little bit. So I'm excited to hear your take, Ed. You've been there for how long forecasting in Myrtle Beach?
Gosh, 32 years. I'm an old man.
I don't know about that, but you have certainly a good amount of experience when it comes to this area. And certainly a good amount of forecasting experience when it comes to severe weather. So let's dig into this severe weather setup. What happened with this expected system that came through? Can you take me through the process from your perspective when you first started looking at this setup and thinking, this is something we should really pay close attention to?
Yeah, I think, several days out when you saw that SPC was basically forecasting 15-30% chance of severe weather, in the Carolinas, that gets your attention for sure. And when you look at the parameters on the various models that we were looking at, they were screaming significant event. We, at least on the models, had enough instability in the atmosphere. The wind shear was outrageously high with very strong winds just above the ground. So it was just a matter of that coming together or coming to fruition as the model suggested. And we were looking at a very significant severe weather event with tornadoes and obviously some damaging wind as well. And then as we were getting closer to it, the numbers kept going up. And then in the end, it didn't pan out as many folks thought it would. And I think the primary reason for that was that the models did a poor job at initiating the thunderstorm activity that occurred out ahead of the main squall line. And for that reason, it really stabilized things. That squall line fell apart and pretty much left everybody with not much going on, which we're all thankful for, but it makes you scratch your head and say, what were we missing?
So at what point did you look at things and say, I don't think this is going to happen? And at that point, did you kind of pull back when it came to communication with the public?
Yeah, absolutely. The morning of on Monday morning and really Sunday night into Monday morning, the models were starting to hint at that pre-trough convection, prefrontal convection, if you will, thunderstorm activity. And when that happened on Monday morning, I'm like, this is not going to pan out as we thought because of how stable the atmosphere had become and how that line had kind of fallen apart. And then there was just extensive cloud cover that was going to make it hard for the atmosphere to recover from that during the course of the afternoon to reintroduce the instability. So I think that morning, and my messaging on Facebook was, you still have to prepare for the worst, but there's a chance that this is not going to be as bad as what we thought. And of course, on television and digital as well.
The SPC has a new kind of addition to their outlook this year. There's like these new levels of intensity, the SIGs. I'm curious as a TV meteorologist, how you, first of all, interpreted that, kind of this being one of the first ones where we're using this, and then also how you communicated that to your audience.
So at this point, we have not used that stuff actually on television, but we have used it in our communication. What I love about it, and as you well know, the old way was you knew that there was a risk of severe weather, but you didn't really know just how big of a risk that severe weather was or how intense it was going to be. You would see the hatch marks on some of the SPC outlooks, obviously. What I like about this is it not only shows you how much severe weather there may be, but just how intense it could be as well. Because we run into a lot of situations where you have very few severe thunderstorms, but they can be high-end thunderstorms producing really high-end wind and tornado damage. Or you could have a situation where you just have a lot of severe thunderstorms with, for the most part, minor severe weather, if you will, where it's not nearly as intense as some of the bigger events. So we were able to communicate that using their new SIGs, which was fantastic. Talking about how this could be a really big event in terms of tornadoes. And as you well know, Emily, in any severe weather outbreak, most people are not going to get severe weather, but on days like Monday, there was always that chance that if you did see severe weather, it could be really, really nasty. And we were able to communicate that because of the new SIG format.
Okay, let's talk about the aftermath here a little bit and the role of a meteorologist. And, I saw pretty quickly, like people putting out their apologies, and I think you were one of them. And like some people even saying like, we blew this, and I'm really sorry. So I'm curious if you think like that's important, or if that can ever like inform the public. Maybe we don't know what we're doing all the time. Like what's the best practices here when it comes to, say, a bust, or even something that. And I wouldn't even call this a bust. I'd call this like, not a perfect forecast. But I'm just wondering like what your thoughts are on maintaining credibility with the public, but also taking ownership over something where mistakes were made.
I really think transparency is the most important thing you can do in any big event, because if you just brush it under the carpet, it's no big deal. I think people kind of get upset with that because they want to know what happened. I also know that inherently we're going to blow a forecast from time to time. The bottom line is we can't sample the atmosphere perfectly. So there are going to be times when the forecast is going to bust. And, you get the forecast right 95% of the time for the next day, but people remind you of the 5% that you miss quite often. So I think it's important to be transparent. I don't know if apologizing is the right word, because you don't have any control over it. It's not as if we missed something. I mean, the bottom line is that the model showed this. My experience as a meteorologist and understanding the model biases, I still went all in on that possibility up until that night before that morning, and then started obviously talking about the possibility of it not panning out. And I think inherently also it's important to not only discuss what the worst case scenario is, but here's what could cause it to bust. That way it's at least in people's minds and they're prepared for the worst.
Is part of the problem too, like our bar is just so high now at this point because forecasts have gotten so good. So if we're not doing it perfectly, it feels like a bust. Whereas like maybe 20 years ago, like you were forecasting 20 years ago, the outlook didn't look like this. We didn't have models. We didn't have high resolution models like down to the hour. So is that part of this? Like we're just so expected to get it perfectly right?
Yeah, I think it's information overload, almost model overload. And a lot of people see these high resolution models down to 3 kilometers that we can use. And they think, boy, look at how precise these models are going out 48 hours. But you always have to go back to precision does not always equal accuracy. I can tell you that, hey, on June 6th, it's going to be 67 degrees. That's a precise forecast, but I don't know if it's going to be right that far out. You know what I mean? So I just think that people just rely so much on model data And so does the general public. It's out there all over the place, and people are looking at their own stuff all the time. But it's a lot of information, and it's hard to decipher that sometimes. In social media, obviously, you run crazy with that, with a lot of folks just looking at it and thinking whatever is on that high resolution model is precisely what's going to happen. And frankly, they did a poor job with this system.
Mm-hmm. Yeah, it's a good reminder of letting go of a little control. We don't have control over everything. What about the viewers? Do you have any feedback from them on what they thought of this? Are they upset? Do they understand? Do they understand the SPC outlook? I've always wondered that.
That's another big thing, because when you hear about slight and moderate and enhanced, I don't know that really sits well with people in terms of them understanding it. Obviously, a high risk, people know that something big is going to happen. But I know that they're doing a lot of social research on that as well to see what works best with the audience. At least from my perspective, overwhelmingly, people in our market were just grateful that they only had some minor issues with, getting to school or getting the kids home from school, or minor inconveniences compared to what could have been. So they were very thankful that it didn't pan out as bad as it could have. Now, if you go the other way, it's an entirely different story. Like, not a big deal, and then you have big tornadoes. But I think overall people were accepting of that.
Yeah, for sure. Ed Piotrowski, is there anything else you want to share about this event or about severe weather forecasting in general?
I mean, in general here, the most important thing is that when we do miss a forecast, it's always important to go back and look at what went wrong and how we can get better moving forward. We're still going to bust from time to time. You just try to minimize those busts as you move forward.
Ed, thank you so much for joining me today to chat this one out.
Always great to talk to you.
Evan Bentley, thank you so much for coming on today to talk about the Storm Prediction Center and the new convective outlook. Lots of good information here. You are the warning coordination meteorologist, right?
That's right.
Awesome. All right. So you're the guy that knows everything about what's going on there at the Storm Prediction Center and can share all of that with us today. Let's start by talking about SPC, because I think when it comes to the general public, and even I know my coworkers, it's hard to explain to them what this is, how this is different from watches and warnings. Can you kind of break down what the Storm Prediction Center does?
Yeah, so we're in charge of this severe weather forecast for the days 1 through 8 timeframe. So in the extended range, we're putting together our severe weather forecast all the way out to day 7 and 8, and then all the way down to the day 1 period. At that point, we go into more of the shorter term weather. So we issue basically every severe thunderstorm watch and tornado watch that's issued in a year is issued from the lead forecaster desk here in Norman at the Storm Prediction Center. Now, one of 5 to maybe 6, if we include fill-in lead forecasters, are issuing all of those watches every year. So it's a pretty small crew of experts who have been doing this for quite a long time who are putting those together. And then once we get, sub watch scale, those watches were generally 3 to 6 hours in advance of severe weather events, depending on if you're in the western part of the watch or eastern part. But then when we get down into the 1 to 2 hour time frame, we issue what are called mesoscale discussions. Well, these are mainly focused towards the weather community. So broadcast media, even emergency management who has some weather knowledge, local forecast offices, letting them know how we see the event unfolding. What corridors we see that might have a greater risk. What do we think the major risk is? And then once we get beyond that time frame, down the sub-hour time frame, that's when a lot of the messaging pieces are passed along to our partners at the local forecast offices, where we get into the warning phase.
Okay. So when folks are hearing like their phone going off for a tornado warning or a severe thunderstorm warning, that is not coming from you guys. That is coming from their local National Weather Service office.
That's correct. Yep.
A huge part of this has to be social science when it comes to what's the best way to get this information out to people. So I want to kind of dig into that and what we're looking at when we look at a severe weather outlook for, let's say, like day 1 or 2.
Yeah, so in the day 1 to 2 time frame, we're basically deciding in many ways at the higher level, what is the message that we want to send on any given day? We've got our risk categories, and they go from marginal all the way up to high. But really, we've heard this from the social science community that the words are confusing. And there's some history behind it. The reason that moderate is now level 4 out of 5 is because moderate used to be the level 2 out of 3. And so really it was just kind of the way that it worked out, that the words weren't perfect, but there's a lot of history behind them. So we didn't necessarily want to get rid of the words. So we de-emphasized them, and we're really focusing more on that level 1 to 5 risk, where we're really, 1 to 2 are fairly common. Level 3, those are a little bit more rare and a little bit more high-end events. And then the level 4 and 5 are ones that are reserved for maybe a dozen times per year for the level 4, for some of the more highly impactful events during each given year.
Okay. And then when you kind of open up the Outlook, you can pull out individual hazards as well. And those are each in a category too?
Yeah, and so that's once we get to the day 2 time frame and then down to day 1, we can say what the risk is from tornadoes, from wind, and for hail. And in the past, that's mainly been a coverage component. So what's the probability of having a tornado or wind report or hail report within a given area? And now here recently, we've added additional intensity information, which really adds a lot more information underneath the hood, especially for those decision makers and the people communicating the message.
Yeah, I am curious, who is the Outlook designed for? Like when you guys are putting it together, who are you thinking is the most important group that's looking at this?
It is our core partners within the emergency management community and within the local weather service offices and the broadcast media. Primarily, those are the 3 people that we're trying to hit. And so it is meant to be a very scientifically rigorous process. Our discussions are not meant for the general public. We're actually specifically, the lead forecaster will read it and be like, that's a little bit too colloquial of a term to use. Let's look at the more scientific way to actually say that, because we are, we consider ourselves here, 40 of the top severe weather experts in the world. And we want to make sure that our products reflect that.
Oh, interesting. I'm curious your thoughts on, because the general public does look at this. I mean, maybe not straight from your website, but is it like computer models where it's too accessible, or people are gaining access to this when it's not intended for them and then it's misinterpreted, do you think?
That's a tough space that we live in, where, our main goal is to be as scientifically rigorous as possible as we're putting these forecasts together and provide the best scientific information to the other meteorologists. But as you mentioned, at the same time, this information is getting out to the public. It's publicly available on our webpage. But you will notice we don't generally just post the graphics directly from our webpage onto our social media, because we realize that is meant for the more general audience. And we do have key message graphics that we put in there where we just highlight the main highlights. And even on our graphics, we have the categorical risk, and maybe we'll have areas highlighted with some intensity information, but we aren't posting, the probability is 45% within this region with a certain intensity level, because that's kind of getting into the weeds. That's important for the meteorologist, but isn't necessarily the best way to communicate the threat to the general public.
Okay, so let's break down the changes. What's new for this spring? Can you explain the differences here in what existed before and what prompted this changeover to more specifics?
This was a challenge we had in the past, is that an EF2 tornado would be treated the exact same way as an EF5 in our intensity information. Because in the past, it was 10% or greater coverage of EF2 plus tornadoes. And so those strong tornadoes and violent tornadoes were in that same bin. And also, we had to have a certain number of them for it to even matter. And so that was a challenge that we had in the past. And so now we've broken it down to where we can have 3 different intensity levels, really 4 if you count that we don't. Below the intensity level 1 is basically we're forecasting mostly weak tornadoes within that environment. Our intensity level 1, it's the same as before. We're saying EF2 tornadoes, but now we're actually saying, that's a reasonable max intensity. And we're not saying there'll be multiple, which we kind of needed before to get 10% coverage. Now we're just saying, there's a chance of an EF2 tornado within this environment today. As we move up to that next intensity level 2, now we're talking about a reasonable max intensity of EF3. And at the high end, that intensity level 3, they're going to be rare, maybe once or twice a year. But these are for those events where violent tornadoes are on the table on those days.
Okay, so the message is more precise. Is the work to create this more like labor intensive or time intensive?
This was a challenge that we had because it was already a lot of lines to move, especially within the software constraints that we have. And so there's a lot of work that went in on the background. I don't think people realize that we only have basically 4 to 5 people who are working on the back end on the entire, science support branch infrastructure to do this. And really, this whole project was on one of our science support branch staff, Chris Carson's in the back, who did a vast majority of the work on the back end to help make sure that these graphics worked. And so the reason I bring that up is because he did some tremendous work to help us. So in the past, there was making sure all your lines lined up, and then make sure the categorical risk wasn't in the wrong. So you didn't have an area where you had a categorical risk that didn't align with the probabilities. He did all of that for us and made it draw your probabilities and I'll auto build the categorical graphic for you. And that was a huge time saver. So yes, there was additional workload, but we did some things behind the scenes to really help ease that burden on us because adding more lines and more challenges in an already condensed time frame was going to be a challenge. And we were able to get out ahead of that.
Interesting. Was there a testing process for this? Like, did you work on this with TV meteorologists or emergency managers to kind of roll this out to see, does this work for the people that are trying to communicate this information?
Yeah, so this was a long process. And the first part of it was really the scientific phase. So back in 2019, we first started testing this in the hazardous weather test bed. There, we've got people from academia, from the research community, from operational meteorologists. We do have a few broadcast meteorologists and emergency management personnel who will come in through that process. And in that early phases, when we started getting feedback on, can we do this? So that was the first step was, do we even have the skill to be able to do this? And we started showing, okay, here's how this might lay out. We started testing it internally. And even after that, we had to make a few tweaks to it. But really within the past couple of years, we had the system finalized. And that was just a matter of, okay, let's take some real-time weather, doing these forecasts in real time, and can we do it? And we did. The verification over a broad sample really showed that we were providing very large discrimination between environments that support weak tornadoes and environments that support the intense to violent tornadoes. So that was promising, and that's what made us ready to go live with it. Now, the communications piece is another challenge, and that's really in its infancy, honestly. I mean, that's within the past couple of months, we put together, okay, now's the final plan. We're ready. There's no reason to hold back the science because that science is there. How are we going to start displaying this? How are we going to start communicating it? And we actually brought in at the very beginning of this process, before we even had released it out to the public, we reached out to some broadcast meteorologists and said, okay, look, here's what these changes are looking like. One, let us know how this training works, because we want to train other broadcast meteorologists so they're prepared to present this information on air before we go live. Tell us what we're looking at. And that was valuable. We did that both internally to the Weather Service as well as the broadcast community. And they told us some pieces to it. They're like, no, that's not going to resonate. Let's rework those slides. And so that was helpful there. And we had those conversations early on with, I even asked them in that presentation, so how would you see displaying this information? How do you see the value there? And really, we kind of worked it out to where displaying that information the same way that it was always done before is probably the best way, because that's been tried and true method for 15 to 20 years and longer, right? In some of these areas. But how can we add that intensity information on there, even if it's just simply with words or dash lines? We don't want to make it overly complicated, but man, there's a lot of extra information that really helps the message piece. So how can we meld the two of those? And that's going to be an experiment here into the future. This spring, I think, is a time frame that we're going to be looking back at. Okay, how was this utilized by people within each different part of the community? And what are some things we can learn about maybe the way we display it on our webpage, et cetera? And we have already gotten some feedback in that regard.
Okay. Anything useful? Like, as a former broadcast meteorologist, I think about this is the graphic I'm showing, but how do you convey these little intricacies with that intensity? Is there a way to do it? Is it a matter of voicing over and zooming in and showing these areas where there could be stronger severe weather? What have you seen that works?
Yeah, to me, the part that there's two pieces to it. One, if you've got a longer broadcast, or let's say if you're doing a briefing where you control the narrative, there's some value to separating it out. There's actually been some social science research that's shown that. Put the probability and the intensity information, separate them. But the issue when you do that is let's say we just did that on our webpage, then you lose the context. If somebody takes the intensity piece without the probability piece, it does not say the whole message. And so, from our perspective, we've kind of focused on the categorical and then highlight inside of there, because the categorical tells you the overall threat. And that really hasn't changed. It's just the additional information underneath. And so we've seen that with the broadcast community too. I think some of the graphics, at least personally, I think have looked the best, is where it's the traditional graphic they've always had with some type of either text overlay or highlighted area or dashed line that says this is the area with the intense tornadoes are more likely. And that really seems to have a lot of value, at least in this phase of it. But once again, we're still in the infancy. So it'll be really interesting to see what other ideas people have as to how to display this information.
Yeah, I guess there's the drawback of digital. People can grab graphics and misuse them, whereas you have that advantage in broadcast where there's a little bit more control. I guess people are less likely to take those screen grabs. When it comes to this in practice at this point, is this improving accuracy? Has it not been long enough that this has been in practice, or have you seen a changeover in how this is panning out with people preparing for severe weather?
Yeah, so there's two pieces to that. The first is what a lot of people don't know, because this is the first stage really in what the intensity information does for our information. Now, by having this information in there, we actually have some Monte Carlo simulations and some internal models where we can run specifically how many tornadoes are expected across the United States on any given day, at what intensity, how many homes may be impacted, how many hospitals may be impacted. I mean, we have a breadth of information behind the scenes that we can now do because of this intensity information. So if some people are wondering why are they doing it, this type of information that we can share with FEMA and the Red Cross and our high-level national partners is invaluable. I mean, that's really the core reason why we're doing it, is because the downstream metadata that can be created from these more precise forecasts is really incredible, and it's really cool behind the scenes starting to see how good some of these things really do. Even if in real time you're like, wow, are we really gonna have that many tornadoes today? And you go and you look a week later and you're like, well, it actually wasn't too far off. And that makes sense because it's built off of historical tornado database, right? So that's how we would expect it to perform. But the value on that on the front end with helping preparedness is really the big piece that we wanted to do as part of this. And so that's what was kind of the big core reason about why we did it, looking behind it. And now here within the first couple of weeks, we've seen I think one of the biggest things, and we're going to have to be looking at this as we look forward, we have different probabilities to categories with the conversion now. And so our categories haven't changed. And so an enhanced day is still an enhanced day, moderate day is still moderate day, but maybe we have some higher probabilities within there than we had in the past. This is to align with our calibration with the reporting that we have today. We have a lot more wind reports, a lot more hail reports, a lot more tornado reports. Those probabilities are higher. And so we were way undershooting our calibration simply because we had created those probabilities 20 years ago when we had a totally different report distribution. And so I think then that's going to be an important piece for us going forward, is making sure that that threat is clear. A 15% coverage of tornadoes with a SIG-1 is only an enhanced. So just because there's a 15 doesn't mean it should be messaged the same way that a moderate risk for tornadoes was in the past. It should still be messaged as an enhanced risk, because that's how this is mapped out, just because it's the same probability that several weeks ago meant a lot different threat, right? And so that's probably on us, that we need to make sure that we communicate that piece.
Is part of the necessity of this new system just because forecasting's gotten so good? Because like my first go-to with this is like, wait, we know that, these are going to be EF3s or higher, these are going to be EF2s or higher. That's wild to me. Has intensity forecasting with tornadoes gotten that much better, like in the past 20 years?
It definitely has. And that's, really, we didn't change anything about the intensity information since the early 2000s. And so this is the evolution of the science. We've gotten there. Our calibrated guidance that we have, which is a lot of it's built off of machine learning and AI, is really giving us a lot of value. There are some times when it definitely steers the wrong direction, but there's other times when it's like, okay, what is it seeing? Because it's trained off historical data. What is it seeing that it is, not as hot for tornadoes today, for example? And it is really helpful as part of our thought process to get calibrated. And that's really what we've shown, is that, this skill set is something that we were ready for. And honestly, we performed better in our experimental period than we even thought we would have. And so that's why we were like, okay, there's no reason not to share this information. That intensity information is something that we can do. And even on another note, I think this was a sign that we were ready to go forward with it, because, we would have internally within the office, even, let's say a couple of years ago, before we were doing any of this experimental stuff. All right, what do we think the peak VROT is going to be, or rotational velocity is going to be on radar at any site in the country today? And we all put our guesses on the board. Somewhere, let's say it's 65 knots at the low end and someone has 84 knots at the high end. And we calculate a median and we're 75. I kid you not, I can't tell you how many times we looked the next day, peak VROT was 73 or peak VROT 77. It is very close to the median there. And so I think that in itself shows that we know, based on the environment, what the expected outcome is likely to be. And as long as the forecast pans out in a similar way to what we were forecasting, we're usually not too far off.
I'm thinking about like the next step. Do you think in the future it might be broken down by this EF scale? Because right now there is a little bit of confusion in the way that we have the EF scale, which is one scale, and then we have these SIGs, which is broken down by 3 categories. But it talks about the EF scale. So is there, I don't know, there's a little confusion with different numbers that align with different things there. Do you think in the future it might be even more precise as far as those SIGs or those groups?
That's a challenging piece that we've talked about and I think part of it is at the high end, violent tornadoes are violent tornadoes. The difference between 4s and 5s oftentimes is just what they hit. And that's something that's kind of outside the forecasting realm that we can really handle. And same at the low end, EF0 and EF1s, we pretty much can lump those together into one group because there's usually not a big difference there either, other than what they actually hit. And now there's some intensity differences there as well, but especially QLCS tornadoes, when they're moving at 60 miles an hour, are almost always EF1, because if there's any rotation at all, you're going to get above 85 miles per hour with those type of tornadoes. And so I think that's part of the reason why we're there, is that we've got weak on the low end, violent on the high end, and really the discrimination is, in that middle piece where we've got the low end, the high end, and then 2s and 3s. We can provide a fair amount of discrimination there. So that's what makes sense right now with kind of the 4 different categories or 3 that we actually forecast for. So it makes sense there for now because of some of the issues related to the EF scale and it being a damage scale, right? But the other piece of it is maybe there are more opportunities for more gradation within the actual intensity forecasting that we can go to, say 10 years into the future, et cetera. But it probably wouldn't be focused as much on the damage scale and maybe more on intensity. Is it a reasonable max VROT from any given day? Something that's more normalized and isn't impacted as much by what did the tornado hit.
This may not be like the job of SPC, but I'm curious too about the impact forecast as far as like this is, the strength and the probability, but do you look at like longevity, how long they're going to be on the ground or how many or what is on the ground? Like, are there a bunch of houses there or is this out in the middle of nowhere? Are those factors that are taken into account at all?
So that's some of the idea of, let's talk about with like the impact modeling that we're doing on the back end. That's the value of that. And actually that impact modeling is not good if we adjust our forecast based on the population density, et cetera. So it's important for us to have consistent forecasts everywhere in the country and let the metadata downstream tell us how impactful it may be. If we start adjusting that, then we're going to end up with overly inflated forecasts in those higher population density areas. And so that's as a forecaster, let me tell you, that's a nice thing to not have to adjust. Oh, well, today I'm in North Carolina, so I have to think about things totally different than yesterday in North Dakota, right?
Yeah.
If we can keep it consistent across the board, which we do, and we really try hard to make sure we're consistent everywhere, that really helps with making sure that the downstream pieces that we can build are accurate.
And then how does the public gain, how do they benefit from that downstream data? How is that impact forecast going to present itself down the line?
Yeah, that's some of the information that we're really curious of. I mean, that's going to be meant more for your decision makers, emergency management community, et cetera. And the decision there is going to be, what is their threshold for, what's a median number of power outages or, a medium number of tornadoes in my area before I need to make different preparedness actions than other days. So that's going to be a question for decision makers. Our job really, we see it to provide the best scientific data possible. And this would be, okay, if we can tell you how many tornadoes might be in your area and maybe how many houses could be at risk on any given day, how does that help your preparedness piece? It's not our job, we really try to stay out of telling them what that means. We provide the information and let them decide how they need to make their decisions.
So we talked about best practices by the people who are using these outlooks. Have you seen any misuse of them? Have you seen anybody do anything where you're kind of cringing?
Well, I think one piece that was, there's been some confusion on early on, because I've seen some of the comments of, well, are we just now going to put a SIG-1 across the entire tornado risk area on any day that has a tornado threat? And the answer is in March and April, yes. I mean, because it is driven by shear. The intensity of tornadoes is driven by shear. And, if you've got strong shear, we can have strong tornadoes that can occur within that environment. And so that will, and I think it'll make more sense once we get into June and July and we have these environments where there is a tornado potential, but the strong tornado potential is just not there. When you've got 20 knots at 850 and, you got some turning, but you could have some tornadoes or along a boundary tornadoes. We're not going to be putting SIG areas in there all the time. I mean, there'll be some cases, let's say the boundary in West Texas where you do get stronger tornadoes on any given year. Yeah, we'll be trying to target those areas, but the blanket across the entire area, you'll see that as we get into the less favorable shear time of year, that we won't just be blanketing the entire area. But in the spring, it's prudent. I think in the spring, we looked at the numbers and it's close to 20% of all tornadoes are EF2 plus in March, April, and May. So yeah, climatology says we should have every single tornado probability in that intensity level 1 this time of year.
Okay, that's good to know. All right, let's talk about our most recent event here. This is a big talker. Massive cold front moving across the country. we see the SPC outlook. There are some very high risk categories here. In some places, definitely verified, other places less so. Can you explain to me the thought process of the SPC through this forecast and how it evolved?
Yeah, in that day 3 to 4 time frame, it was looking like a very concerning forecast. We were talking with over 1,000 joules of Cape east of the Appalachians, and an environment that had extremely strong shear. Mid-level, with 700 jets, 70 to 80 knots, mid-level jet over 100 knots across this area. And we see this a lot with basically little instability at all. And we end up with a lot of people that end up with wind damage associated with these events. In this case, we were looking at even greater instability with a really strong storm system. All the pieces were there that it was a very concerning environment. And we felt it's important to get the word out in this, that we could have a lot of people impacted by severe weather, on that Monday timeframe. And so it seemed prudent, definitely at that timeframe, to make sure that we got the messaging out early. As we got closer, it started, there started to be some concerns, even still looked pretty good, even, on Sunday. I remember Sunday morning, even we're looking at the forecast, over in the Midwest, and we're still looking at the next day. And it's like, today looks pretty good here, but tomorrow still looks like it could be even worse over there in parts of the mid-Atlantic. And so it really wasn't until when we got closer to the event that we started having some issues develop with it. So one was when we were looking at that guidance farther out, there was no precipitation whatsoever really out there in the warm sector. If we had it, maybe it was an isolated, scattered storm, which actually would also be bad, because a lot of times those are the ones out by themselves without any storm interference that can cause your more significant events. And we were discussing that possibility. But then the other piece is when that squall line came through with the front, it was going to pack quite a punch. When we got closer, we ended up with a bunch of storms that developed, ate up all the instability that the storm could utilize. And we did end up with strong winds along the front. We ended up with, I think I looked this morning, we're close to 500 wind reports. And so the wind side really wasn't that far off. On the intensity piece, if we're looking at it after the fact, it's probably a high coverage, low intensity type event is where it verified, which is still an enhanced risk under this system. And so a moderate versus enhanced risk on the wind side isn't really, that happens in weather. To try to be perfect all the time is a futile cause, right? That part wasn't that far off. The tornado side definitely was, and that was because we had all the storms that ate up the instability. There were too many of them interacting with one another to really, take advantage of the environment. We also, instead of having pretty strong height falls and strong forcing during the day, that waited until later in the evening, just the way that the trough evolved as we approached the event. So really that piece of it, the tornado forecast didn't really work out quite the way that it was looking like it would 2 and 3 days out.
Was that sort of forecast not panning out, was it uncommon, or was it just taking the center stage because maybe the areas it was covering and they're, high population areas, so people are talking about them? Do you think just like the increase in the number of digital meteorologists, there's just more buzz about it? Like, what do you think the reason for all of that was?
Well, I think this is one piece that we need to look at the communication side, because we had a 15% hatched area or intensity level 1 for tornadoes, which in the new system is an enhanced risk. So really this whole time we were forecasting wind moderate, tornado enhanced. And so we were never saying that tornado was the primary threat, even though that was what ended up being communicated a lot. And part of that might be because several weeks ago, a 15% intensity level 1 was a moderate risk for tornadoes. That 15% meant something different then. And so that, there's an opportunity there for maybe us to make sure that we communicate that better, that, this was still just an enhanced tornado day, even though we had those 15% probabilities. And that might have contributed somewhat to it. And that's some of the challenges with communicating this new system, is that those probabilities are going to be a little bit higher. Same on the wind side. We had a 60% wind probability, which would have been a high risk under the old system. But we've now allowed ourselves to have that additional coverage information in there to align better with the reports that we're getting today. All of us are really trying to readjust to what the new categorical to probabilistic scale looks like.
Yeah. I think too, it's like the narrative that goes out there on social media too. And I saw a lot of meteorologists like apologizing and saying the B word, bust. What do you think about that? Like, do you think it's necessary to kind of go back and do a post-storm analysis? Or do you think it's like, all right, the next one's right around the corner, let's move on. Let's just keep plugging away and get used to this new system?
I'll tell you this much. Nobody takes it harder than we do. We are our own biggest critics. And that's every single day. I'll tell you this much. There's no sense of, oh yeah, that happens. All right, let's move on. it was a somber mood in the operations floor because we realized that, we had messaged a higher end event that was not going to occur quite the way that it seemed to be. And, that's not really what we want. I mean, we're really trying to target the best possible forecast. And we don't love that. And the other piece is we're always looking back and what can we do better the next time? What can we improve on? And so it is never taken lightly on our part. And the thing that I think people don't realize is events that oftentimes maybe we're receiving praise for of, oh, wow, look at how well this event forecasts. There's very little of that usually internally. It's, oh man, yeah, but that area over there, look at that, the whole western 2 rows of counties in the moderate got nothing. I shouldn't have gone so far west. We are our own biggest critics in it. And so, there's, people can call it a bust or call it whatever they want. But we're already aware. We're evaluating on a daily basis. And the longer you do this job, the longer you try to forecast the future and forecast severe weather, the more doses of humble pie that you are served.
Looking into the future, not an easy job. Evan, thank you guys for all that you do at SPC. Is there anything else you want to share or you want the public to know?
This is kind of the first step. That intensity information, there's going to be some cool stuff that's going to be coming out into the future, definitely into our internal partners and probably eventually into the public realm as well, that really shows the value that this intensity information is adding underneath the hood.
Do you want TV meteorologists and emergency managers to get creative with this when it comes to ways to convey this to the public or ways to just share hazard information with the public? Are you hoping to see some cool stuff out of these communicators?
Yeah, that's exactly what we're looking for. Because oftentimes as scientists, we think information is best displayed one way. And then we end up talking to the people in that community and they're like, yeah, I know I can't show this to my emergency operations center. The message is not going to get across right. And so that's how we learn, is by them saying, hey, I realize that this graphic works really well with my partners. Just wanted to share that with you guys and let you know that this is a way that they really seem to understand the SPC risk outlooks well. When we can see that back on our end, that's helpful for us to iterate and be like, okay, are there ways that we can use that for similar partners to convey some of our information? Because while that is a secondary role, beyond the being number one, being the scientific integrity, the best possible forecast, we are trying to make sure that we have the communication piece done the best way that we possibly can, even if that's limited to only a few of us. And, specifically me as a warning coordination meteorologist, I kind of am that liaison between the science and trying to get the communications piece. And so there's not a lot of us, some of the forecasters dabble in it to some degree, and a lot of that really falls on me. And so I'm probably more curious than anyone at some of the ways that we can really help with this communication side.
Cool. Well, it's a work in progress, and we appreciate all that you guys are doing. Evan Bentley, thank you so much for your time today.
Thank you, Emily. I was enjoyed talking with you today. We got into a bunch of great topics. This is really fun.
Yeah, for sure. Off the Radar is a production of the National Weather Desk. Make sure you're following the show on Apple Podcasts, Spotify, or wherever you listen to podcasts. New episodes published every Tuesday. Thanks to Evan Bentley and Ed Piotrowski for joining me on the show today. If you like what you heard or you know someone that's interested in learning more about severe weather forecasting, please share this episode with a friend. You can also rate and review this podcast on Spotify or Apple, and feel free to comment on YouTube as well. Just search the National Weather Desk and find the podcast playlist. You can listen to all past episodes there. Thanks to the National Weather Desk and Sinclair Broadcast Group for their ongoing support of the podcast, and to Brian Petras for his help on today's episode. I'm meteorologist Emily Gracie. Make it a great day.